Assalamualaikum and a very good day. Today, we will be presenting a project titled Alternative Clean Water Production by using Cocos Nucifera waste based in solar vapor generator. This project focuses on finding a sustainable and low cost to the global clean water shortage. First of all, let me introduce myself. I am Azri Nazira binti Muhammad Jaafar and my partner here.
I am Nur Afrina Najwa binti Ahmad Rusdi.
I am Nurul Atika binti Muhammad Razif.
The interface solar steam generation ISSG technology has shown great promise in addressing the global freshwater crisis. However, stark crystallization remains a major challenge that limits its evaporation performance. Similarly, solar-driven interfacial evaporation has emerged as a powerful approach to tackle freshwater scarcity worldwide. To enhance this process, coconut coir fiber presents an interesting potential material. It contains about 46 lining by making it one of the natural fiber with the highest lining. In addition, coconut coir is a lignocellulosic material mainly composed of cellulose, 32.69%, lining 42.10%, and hemicellulose is 22.56%.
Objective of our project is to design a solar vapor generator that maximizes water evaporation and salt removal efficiency using agricultural waste by using carbonized coconut like coconut dregs, coconut husk, and coconut shell. The second objective is to identify effectiveness of removing salt in seawater using Cocos Nucifera in terms of water quality like salinity, pH, turbidity, chemical oxygen demand, biochemical oxygen demand, and heavy metal. The problem statement is the cost of desalinated water is usually higher than other water sources because the process needs a lot of energy to remove salt from seawater. This makes the operation expensive and increase water and electricity bills for consumer. To solve this problem, our project aims to produce clean water at a lower cost. By using solar energy and coconut waste materials, the system can reduce energy use and cost, making it more sustainable and affordable. The second problem statement is there are 28 countries in the world that face serious water scarcity, where each person has less than 1,000 meter cube of fresh water per year. This amount is not enough for daily needs such as drinking, farming, and household use. Because of this shortage, many countries struggle to get clean water and must rely on expensive methods like desalination or water import. Our project aims to provide a sustainable way to produce clean water using solar energy and coconut waste materials.
The study began with the collection of coconut shells, husks, and dregs, which were cleaned with tape and distilled water to remove impurities, then dried through air and oven drying to eliminate moisture. The dried materials were crushed and sieved to obtain uniform particle sizes before being carbonized at 300 to 500 degrees Celsius in limited oxygen conditions to produce porous carbon. So we decided to dry shells for 450 degrees Celsius for 15 minutes, husks 400 degrees Celsius for 15 minutes, and dregs 300 degrees Celsius for 10 minutes. A solar vapor desalination system was then constructed using transparent acrylic sheets and an absorption base with decarbonized materials placed on a floating platform to enhance solar energy absorption. Saline water was added and the system was exposed to sunlight to produce condensed desalination water, which was collected for testing. The desalination samples were analyzed for turbidity, pH, salinity, COD, BOD, and heavy metals using standard instruments and alpha methods. The performance of the system was then evaluated based on the water quality improvement, salinity reductions, and compliance with Malaysians and WHO water quality standards, while ensuring proper safety procedures and waste disposal throughout the experiment. The refractometer reading shows that the initial salinity of the sample was 3 G per ml, while the measured result is 2.8 G per ml. This means that the actual salt concentration is slightly lower than the expected value. The small difference of 0.2 G per ml may be due to minor measurement errors, temperature variations, or slightly inconsistencies in the sample. Since the refractometer is calibrated at 20 degrees Celsius, any temperature change can affect the refractive index and slightly after the reading. However, the result of 2.8 G per ml still falls within the acceptable range according to the standards, indicating that the measurement is reliable and the solution has low salinity with the salt fully dissolved. to improve the results and reach the target salinity more accurately, better temperature control, more precise mixings of the solutions, and ensuring consistent sample preparations can be done to minimize variations and enhance measurement accuracies.
The first target group for our project is water-scarce countries that face clean water shortage such as Saudi Arabia, Maldives, Namibia, and Kuwait. These areas have limited fresh water and depend on expensive desalination, so our project offers a cheaper and eco-friendly alternative. The second target is coastal and island communities, small island and coastal villages where seawater is plenty but fresh water is limited. Our project can help them produce clean water using the free solar energy and local coconut waste materials.
The main target of this project is to remove salt from seawater to produce fresh water through a solar-based evaporation system. This project uses Cocos nucifera waste material, including the hulls, shells, and dregs, as a part of the solar vapor design. By reusing this coconut waste, the project also helps to reduce agricultural waste and support sustainability. The system works by using solar energy, a renewable and clean source, to evaporate seawater and separate the salt. As a result, it produces distilled water suitable for non-drinking purposes such as irrigation, cleaning, or daily use.
The first highlight of our project is we use solar energy as the main power sources, making it renewable and cost-free. Second, we utilize Cocos nucifera waste materials as natural filters or absorbers to enhance water evaporation and purification. Third, our project is suitable for water-scarce regions where conventional desalination too expensive or unavailable.
This project aimed to reduce the salinity of seawater using a solar vapor generator made from Cocos nucifera waste materials and a Pew binder. The initial salinity for the seawater sample was 3.0%, but after filtration and the solar vapor process, it only decreased slightly to 2.8%. This shows that the system was not effective in removing salt from seawater. The weak performance could be due to limited evaporations, low heat absorption, or too much point that blocked vapor formations. Although the desalination result was not successful, the experiment provided useful experience for improving the design, material ratio, and solar efficiency in future studies. The presence of PU binder may also have a small influence on the reading, as it can slightly change the optional properties or density of the sample. The PU binders plays an important role in improving the structures, strength, and water resistance of the material used, helping to maintain stability during testing.